Alright, so in this video I'd like us to implement the basic displacement shader that is going to conclude all of the functionality that I'd like to put in our HDRI material. So we saw on the whiteboard we're going to be creating a displacement shader that will complement our surface shader, and the core functionality of our displacement shader is going to consist of a displace along normal VOP, which we're going to use a texture to drive the displacement, and it's going to output a modified position and normal of the point that we're rendering. They get fed over to our surface shader, which obviously is going to affect the final rendered look. So we can jump over into Houdini. Here we are inside our material, and I want to create a new VOP Vex displacement shop. And I'm going to name this to HDRI underscore displacement shader. And we're going to take the output of this and wire it into next for our material, and that means that the displacement shader and the surface shader together will combine to define the final visual result of our material. So let's jump inside our displacement shader, and as we said on the whiteboard, the core of our shader is going to be a displace along normal VOP, and we can see that the displace along normal VOP is going to take in a position, it's going to take in a normal, and without doing anything they are automatically wired to the position and normal at the point that we are rendering currently. It's going to take in the amount we wish to displace, a positive value in the direction of the surface normal and negative value against the surface normal. We can also scale this amount, so a scale of 1 will give us that value, but we could scale that down. Really useful when we're using a texture map for displacement, because we can scale that displacement, and they are really the core parameters that we're going to be dealing with. We're not going to be looking at the other parameters on this VOP, but with those 4 parameters, it's going to use the amount and the scale to displace the current position along its normal, and that's going to give us a displaced position and a displaced normal. And we can take those and we can output them from this displacement shader, and that means we're going to be affecting the position and normals of all the points we are rendering. Now we want to drive the amount by a texture map, so I'm going to create a new texture VOP, and before I do anything else I want to create a new UV coordinates and wire S into S and T into T. So let's rename this texture VOP to displacement texture, and I want to take our map, the texture map that we're going to be driving our displacement with, and I want that to be a parameter. So this is going to be our displacement map, and let's take that as our parameter name as well, and let's set the parameter label to displacement map. Fantastic. So we've got our displacement texture, and the output of this texture is a color, and I really want just a single value, so we're going to take the luminance of that color. That will give us a single value, and we could go ahead and output this into our amount, but if we did that, let's think about what we'd be getting. In our image we're going to be ranging between basically a black and white, which is going to give us a luminance that goes between 0 and 1. If we simply took that and fed it into the amount we're displacing, that means that with a value of 0 we wouldn't displace, and with a value of 1 we displace in the direction of our surface normal. We already said that with black in our image we want to push into our surface, and with white we want to pull out. That means our center point now is a 0 value, if you will, doesn't need to be black. It needs to be in the center between black and white. We basically need to offset our values so that black becomes a negative value to push the displacement into our surface, white becomes a positive value pulling that displacement out. We can do that very simply. If we were to take our luminance and wire it into an add constant, we can simply subtract from our luminance 0.5. That means that 0.5 now is our center point. So let's think about that. If we had a black value coming out of our image and we subtract 0.5 from it, we'd get a negative 0.5 as the result. We'd have a negative value that would push into our displacement. If we had 0.5 coming out of our luminance and we subtract 0.5 from it, so a 50% grey, that now becomes a value of 0. It becomes a null effect. It has no impact whatsoever on our displacement. If we had a white value, a value of 1, and we subtract 0.5 from it, we'd get a positive 0.5 as a result, giving us a positive displacement. So by offsetting by negative 0.5, we've now moved the central point in our image to 50% grey as opposed to black being the area of the image that has no effect on our displacement. And we can wire the output of that into our amount. I'd also like to create a parameter to control our scale. So I'm going to middle click on the scale and create a new parameter node. And the only thing I want to change is the label to displacement scale. And with that, that is our basic displacement shader implemented. So I'm going to bring up the type properties of our material, and let's create a new folder under our shader. And this is going to be our displacement folder. And we're going to promote up from our displacement shader. I'm going to promote up the displacement map and the displacement scale parameters, making sure we're not prefixing names or labels. So let's promote those up, and with those promoted we can accept. And I can bring up the parameters, and let's just move these real quick. And we can see here we have the texture that we're using to displace, and we have the ability to scale that texture. So the first thing I want to do is set this texture over to our black and white checkerboard texture. And with that in place, let's now do a very quick test render. Now, to do this test render, I want to hide our teapot. And let's look through our camera and then back off just slightly. I want a very clear view of just this ground plane. It's going to make the displacement very obvious to us. And I guess it's going to be, just so we have a very quick pass to render, I'm just going to set our take over to fill, and I'm going to render the current view. And we should see, with any luck, we should see our displacement, but we should also see a number of artifacts on our displacement. We can talk about those in a second. So let's just give this a second to render. End place should pop up any minute now. There we go, fantastic. And we can see indeed our black and white checkerboard is being used where white is pulling us out and black is pushing us into the surface, and that is affecting our lighting. We can see the way the fill light is being generated there is being affected nicely, but look at all these artifacts. These artifacts come from the fact that we are still using the default settings, if you will, in Mantra for dealing with displacement. And we need to tell Mantra, we need to instruct Mantra that it actually needs to work with that displacement in a different manner in order for it not to tear. So what we actually need to do, we need to add some render properties so that those properties get sent to Mantra and Mantra knows how to deal with our displacement. So I'm going to minimize this. I want to make sure I'm back in the main pass now that I'm making changes to our network. And I'm going to go ahead and let's minimize that, jump into our shader, into our displacement shader. Actually, let's jump back up because we're going to create some properties, and to do that I want to create a properties shader. And this allows me to place properties on this material, which if that material is being rendered and if those properties haven't been overridden by a higher level in the hierarchy, again this isn't a focus on rendering properties, but we could for example set properties on the output driver on Mantra 1 and they would take precedence over the properties in our material. But let's just stipulate that for this basic sort of setup we're only ever putting properties in materials. That means any object being rendered with this material is being rendered with this set of properties, and if we were to bring up the parameter interface for that property shader, we can promote a whole load of rendering properties onto our property shader, and the settings we set for those parameters are the settings those properties have when we render. So let's bring up the parameter interface, and I'm going to jump over to from rendering, and let's set our filter to displace so that we get displacement based properties, and we're dealing with Mantra 10.0. that's the renderer we're using. So let's jump into Mantra 10.0, then into the shading folder, and you'll see we have 4 different parameters that deal with our displacement. So I'm going to promote those over and accept. And now if we take a look at our properties, we can see we have these 4 different parameters that deal with displacement. So what do these parameters deal with? Well, let's take a look at the artifacts we're getting here in terms of displacement in our render. And what we're getting, you can actually see there's quite distinct horizontal lines in our artifacts. And that's due to the way that Mantra renders. Mantra's going to render in what are known as buckets, in small strips of our image. And the problem is our displacement's very large at the moment. And because of that, we're pushing our displacement, our point that's being displaced, out of one bucket and into another, and that's causing some of these tears, some of these artifacts. To deal with that, we have the displacement bound parameter. And this basically tells Mantra how far we're displacing. So we need this to be large enough to encompass our displacement, and that will resolve our tearing. However, the larger that value becomes, the slower our render is going to be. So we need to set it just large enough to encompass our displacement, but not so large that we're slowing our render down for no reason. The displacement space parameter allows us to specify which space, which measurement space this is being measured in, so world space or object space for our displacement bound. And then these other two parameters don't really directly relate to the tearing that we're getting, but redicing allows us to tell Mantra to recut up, if you will, a displacement shaded surface, and that will produce a more regular mesh. And this is really useful if we're using very extreme displacements that cause the distortions of micropolygons. And then true displacements is going to toggle us between whether we're doing true displacement or really just doing bump mapping. In terms of true displacement, that's when we're really moving that point. We're moving the physical p vex variable. We're changing that value, and that point is truly moving. And that means that it's moving in terms of our rendered image, because a point that would be down here is now being moved up to another location. That could affect its surface shading, but it's also going to affect where it appears in our image. If we turn that off, we're only going to affect the surface normal. We're not going to affect the position of the point, and that means we're just getting bump mapping, where we're affecting the lighting because the normals are used for lighting, but we're not affecting the position of the point. So with that knowledge, we can set our displacement bound, since we know that's what's going to be affecting our tearing. And I've worked out that a value of 0.3 with the default grid and the shader that we've got applied currently works really nicely. So if we set that to 0.3 and re-render, we should be able to see nicely now that we don't have any tearing. And also, to better accentuate the fact that we're dealing with a displacement map, I want to render with our diffuse lighting pass. So let's render that, and we should see we don't have any of the tearing artifacts, and we can also see much more clearly now how this displacement is taking place. So we can see we have these areas being pulled up, and we have these areas being pushed down, and it's affecting both the position and the surface normals. Now we're dealing with a very extreme displacement here. That checkerboard texture is not an ideal displacement, but it is proving a purpose here because it is being very useful for testing out our displacement. And we can see we're not seeing any of the artifacts that we were getting previously. Fantastic. So let's just let this finish rendering just to ensure we're not seeing any artifacts. Certainly doesn't look like we're getting any tearing that we were getting before. And then we can promote those properties up onto our material so that every time we create a new instance of the material, there we go, so there are no artifacts. Every time we create a new instance of the material, we're able to set these properties differently, because obviously every object that we're assigning a material to may need a different displacement bound. We may only want bump mapping rather than true displacement, or we may wish to redice the displacements. So I'm going to bring up the type properties of our material. Here's our displacement, and from our properties, I'm going to bring over those four displacements parameters. Now I do want these to be at the bottom of our displacement, and I'm actually going to create a new folder which I'm going to call Mantra Properties, and I'm going to place those four parameters into that folder and accept. So now if we bring up the parameters for our material, when we create our material, and let's make sure that we're not in the take that we were in, and actually that could well have messed up. Let's just make sure. So yeah, indeed, that did mess up the parameters that we promoted because we were in a take. So I just want to make sure that we go ahead and bring up the type properties, and let's delete out these four parameters and accept. Let's delete out our properties node. Let's create a new properties shader. This shouldn't take very long at all. From rendering displace, there they are. Promote them over, accept, displacement bound of 0.3. And then let's bring up the type properties for our material from nodes. There's our properties. Fantastic. And that's now working correctly. The problem we had before was I promoted up the parameters, but I was set to a take, and that means that a number of things that happen under the hood aren't allowed to happen because we can't manipulate certain parameters when we're set to a take other than main. So I just went ahead and basically undid the work we just did, set ourselves to main and reset it all back up, and it doesn't take any longer than about 30 seconds. But now if we look at the parameters, we can see we can specify the displacement bounds, we can specify what space that is in, we can redice, we can turn off true displacements to just get bump mapping, and all of that can be customized from a material to material basis. So that's dealing with the properties we need for Mantra and dealing with our artifacts that we were getting, but we really need to consider one last aspect of the displacement of our surfaces, and that's that we might not always want to have displacement. So inside our displacement shader, I'm going to create a new switch VOP, which I'm going to name to switch displacement underscore P for position. And when we're not displacing, I'm going to output just our normal P from our global variables, and when we are displacing, we're going to output our displaced P, and I'm going to pipe that over to our result. Let's create another switch. This is going to be our switch displacement N. And so again, when we're not displacing, let's just output, let's just resize that back, output our unaffected normal vector. When we are displacing, let's output the displaced normal vector, and let's wire the output of that into N. So now if we drive the switcher based on the idea of do we want to displace or don't we want to displace, and that can be a toggle when we're not displacing, we're simply taking the position and the normal and we're just outputting those back out, and we're not calculating, not evaluating all of this displacement. When we are displacing, we calculate the displacement, that's going to affect the position and the surface normal, and that's what we send out of the shader. So I'm going to middle click on our switcher input, and I'm going to give this the parameter name of use displacement. Also make sure we set that for the name of the node, and this is going to be use displacement question mark, and obviously I'd like the default in this case. Well, firstly I want it to be a toggle, and I want the default to be turned off. We also want to take the output of this and use it to drive the normal switcher as well. So we have this one parameter, and that's driving are we displacing or aren't we displacing. And I can bring up the type properties of our asset, and I want to promote from nodes, from our displacement shader, I want to promote use displacement. So I'm going to promote that up underneath displacement as our first parameter, and I'm going to turn off all other parameters when we're not using displacement. So disable when use displacement is equal to 0. Let's copy that and paste it for scale and paste it for our 4 properties as well, and accept. And now if we take a look at our material parameters, if we're not using displacement, we're not setting anything, and if we were to very quickly switch over to just our fill pass will work nicely, and render. Just give this a second to render. You see no displacement whatsoever happening there. Switch back to main. We can turn on displacement, all of our parameters become available. If I switch back to fill and re-render, and wait for this to re-render, we can now see we are getting displacement calculated. Fantastic. So let's switch back to our main pass, close out these parameters. I'm going to jump over to our network editor, and I want to jump right up to looking at our material because we have now completed our material. So I'm going to right click, and I want to save out, and due to my very small resolution I wasn't seeing that there we go. I want to save out our operator. So that's going to save out all of the changes we might have made, and it's going to save it into the OTL file. Then I'm going to right click and match the current definition to lock out this instance of the shader of the material so we can't make any modifications. And that is going to complete our HDRI material asset. Now, the various passes it outputs and the parameters that it gives to an artist really provide a huge amount of control and variety for creating photoreal renderings of various surfaces when we're using an HDRI environment. And that was the focus of this DVD, how we can use HDRI lighting information and take that into a shader and use it to drive a shader such that we can get photoreal diffuse and reflections, and how we can combine those. We've added a little bit of displacement just to add some more detail, but the focus really was on how we can work with and make use of an HDRI environment for photoreal rendering. And I think we've achieved a very nice shader as an end result. And in the next video, we're going to actually walk through how this asset that we've created can be used to render 3 very different surface types. We'll look at how we can render a rubber type material. We'll look at how we can render tire rubber. We'll look at how we can render a sort of chrome metal material that's more a rougher metal, so it has quite rough, quite blurry reflections. And we'll also look at how we can fake a car paint material using this shader as well. And hopefully the next video will bring everything that we've already learnt so far together, and it should show how it can be applied to a practical scenario. But with that, that does conclude the creation of our HDRI material asset. So thanks a lot everyone for listening. I really hope you've benefited from these videos, and do be sure to head over to 3dbuzz.com and post your thoughts, any feedback, any suggestions, any questions. Head over to 3dbuzz.com and be sure to post over in the Houdini forums there. So thanks again everyone, and I hope to see you guys soon. Cheers.